All right, here we are. Hello, everyone. It is great to be back with you on FSMA Friday, where we celebrate all you food safety fans, you hazard analysis heroes, and you preventative control pros out there. My name is Jim Albright, and today we are talking about hazard analysis. Do you really know what's in your existing HACCP plan, or even if your control measures are actually controlling anything? Well, we're going to get into all of it. But first, for those of you who are new to FSMA Friday, thanks for joining us. We're very glad you're here. This series is a collaboration between the Acheson Group, who is a global leader in food safety and compliance consulting services, and SafetyChain, the group responsible for the world's best digital plant management platform to help food and beverage manufacturers digitize plant-wide processes to make faster, more informed decisions for optimizing compliance and production operations. Now, FSMA Friday is your place for updates, insights, and guidance around the Food Safety Modernization Act, and it's your chance to get questions answered by our food safety experts who join us each month. Okay, it is my pleasure now to welcome back Kate McInnes, the Director of Food Safety over at the Acheson Group. Now, Kate has a tremendous amount of experience ranging from poultry to plant-based products, and I'll never forget this discussion we had with Kate on this, but edible insects. Now, Kate is, yes, Kate is a champion of continuous improvement with a deep experience in helping food companies build a robust HACCP plan. So we're happy to have you, Kate. I know you're a HACCP instructor, and we're going to learn a lot from you today. So thanks for joining us.
Thank you for inviting me today.
All right. So before we begin, I guess we have some FSMA updates here for you to go through.
Yeah, just one today, so it's a quick update. Just that the FDA has decided that they will no longer have announced international inspections. So if you are an international facility that works under the FDA regulations, you will no longer get notice that they are coming to inspect you. So they will just show up and walk through their inspection. You know, a lot of international facilities rely on that 30 to 90-day notice period to make sure that they can be prepared for their visit. And unfortunately, they will no longer get that. So if you are an international facility, keep that in mind as we move forward.
That sounds like fun. Okay.
Doesn't it though?
Well, speaking of fun, let's dig into some HACCP prep here.
Perfect. So today we are going to focus on hazard analysis. So before we dive in, what actually is a hazard analysis? So a hazard analysis is a process of identifying and evaluating hazards that need controls to keep food safe for consumers. As food safety professionals, we work with hazard analysis every day. It is the foundation of everything that we do. And there have been some recent changes with the curriculum for PCQI around how to complete a hazard analysis and some of the requirements there. So in addition to, making sure that we're updated with the new requirements, how complete is your hazard analysis? Next slide, please. So when we're talking about hazard analysis in our food safety HACCP plans, there are two components that we need to give consideration to. So we want to look at those incoming materials. We want to focus on the ingredients and the packaging that we're bringing into our facility and using to manufacture our products. But we also want to give consideration to those processing steps and the flow that our ingredients go to make that end product. So here we're looking at our ingredient process points and any employee handling within that manufacturing facility. So how are our ingredients being handled? And when we're looking at process steps, we want to give consideration to what's going on in our facility, but also at supplier facilities. So what is going on in those facilities that are supplying those ingredients to us? And we're going to talk a little bit about all of that today. But first off, correct hazard identification is the most important step in a food safety plan. If hazard analysis is incomplete, the system may not be adequate to potentially identify those food safety issues. So we really want to make sure that we have done a comprehensive job with our hazard identification in our hazard analysis. Next slide, please. So the food safety plan and the hazard analysis is only as good as the team that oversees the development and implementation of this plan. So it's really important when we're developing these hazard analysis that our team fully understands the hazards that are associated with our ingredients and with our process to ensure that this plan is as robust as possible for our facility. Next slide, please. So that being said, how well do you know your hazard analysis? Did you actually develop it or did you inherit it? If you developed it, did you work through the process of really identifying what those hazards are and coming up with the methods to control it? And if you didn't actually develop it, you inherited it from somebody else or from another team, have you actually asked yourself the following questions? Have you critically evaluated the information that is in that plan, or have you just taken it at face value? Did somebody walk through that plan with you and say, here's all the hazards, this is how we control them, and we just go ahead with that? Or have we actually critically asked ourselves the questions about whether or not those hazards are relevant and whether or not they need to be included in our plan? Have we walked through the process flow to actually verify its accuracy? So we all think we know our process super, super well, but have we actually captured everything in that process flow? Have we ensured that all hazards have been accurately identified? So when we're looking at the hazards that are identified in our plan, are they all the actual hazards that exist for those ingredients, for those processing steps? Have all of our hazards actually been adequately controlled? Do we have control measures in place? And have we challenged the control measures that actually exist to ensure that they work? And why do I ask all of these questions about your hazard analysis? Next slide, please. Because these are all of the questions that are associated with some of the common issues that we see with hazard analysis. So when TAG goes in and does assessments of hazard analysis, we typically see issues around how the ingredient hazard analysis is completed. We see issues around completeness and accuracy, calling out the correct hazards, actually making sure they're identified, and that the control measures are adequately in place. We see issues around grouping of those ingredients. And we see issues around things that I'm going to call the RTE ingredients. So we'll go into a little bit more details about what this means in that section. We see issues around process flow, making sure that your process flow completely identifies all of the steps that your ingredients go through to make that final product. And then around those control measures. So do they adequately control the hazards that are identified? And can you sufficiently prove it? So whatever control measures that you have implemented, do they adequately control that risk? Next slide, please. So in order to guide us through this presentation today, I've created us a little example. So welcome to my Cakes R Us bakery. Here we make this lovely looking slab cake. It's a fairly basic process with some fairly simple ingredients, but some of these fairly simple ingredients can pose a big risk to our potential product and our consumers. So as we walk through today, we're going to use some of the ingredients here and some of the process steps that are going to go into my nice little bakery example to walk through some of the common issues that we see with hazard analysis. So in this example, we have some basic ingredients, including things like flour, sugar, cinnamon, butter, eggs, baking soda, typical cake ingredients, but they're going to demonstrate to us what these issues look like. So next slide, please. So we're going to start by looking at some of the common issues with ingredient analysis. Next slide, please. So focusing on that completeness and accuracy component of our hazard analysis. So do you know where your hazard information came from? Is this actually written down somewhere in your hazard analysis or your food safety plan? Can you conclusively say that, yes, I got my information from Appendix 1. This is the FDA criteria around what hazards need to be considered in your food safety plan. If you are under FDA regulation, they are going to want to know that you understand that this exists and that you have used this as a guideline when developing that hazard analysis. If you're in manufacturing in Canada, have you gone to the RDHI? Do you understand what the CFIA is calling out as those potential risks to your products? Have you used both? Have you cross-referenced them? Have you used horizon scanning? Have you looked at the relevant recalls that have happened within your industry, within the commodity that you manufacture? It's really important to understand where the information from your hazard analysis came from, because you want to be able to scientifically back up that that is actually a risk within your ingredient and within your process. So these are some great guides. When you are going through your food safety plan, when you're going through your HACCP plan, make sure that you actually have a reference in there that says, this is where my hazard information came from. This is what I have used to support my plan. So these are the examples, again, that outline the ingredient potential risks for flour. So flour is going to be an important example today that's from my Cakes R Us bakery. And so we're going to walk through a little bit more detail about what this looks like for the example shown there, which is flour. Next slide, please. So are all relevant hazards assessed? So if you have gone to this guidelines, you have gone to this guidance that says, hey, here are the hazards that we need to give consideration to in our plan, then we should probably be making sure that they're in our plan. If they are referenced by the FDA, they're included in that guideline, make sure you're giving consideration to them. So in our example here, we're going to look at flour and the biological risks that are associated with flour. So the FDA has outlined here that we have a number of different pathogen risks. We need to give consideration to Bacillus cereus, Clostridium botulinum, E. coli, Salmonella, Listeria, fairly typical pathogens that we would consider in a food safety plan. That being said, we also see this nice little one next to the X's around Bacillus cereus and Clostridium botulinum. These may have the potential to be a hazard for your product, but it's going to depend on the final composition of your product. So if we are manufacturing something that we know is going to be stored under anaerobic conditions for the shelf life of that product, we are going to want to make sure that we consider something like Clostridium botulinum, because that does become a risk when we create that anaerobic environment. That being said, in my nice little cake example here, probably not going to be a risk because we're not going to store our cake under any sort of anaerobic environment. But Bacillus cereus, which also has a nice little asterisk there that says, hey, you know what, under certain conditions, we need to give consideration to this, is a risk that we're going to need to consider. Why? Because with our cake example here, our hydrated batter that we're making as part of our process does create an environment where Bacillus cereus growth can occur. And the challenge with Bacillus cereus is because it's a toxin former, if we give it an environment where it gets super happy and makes nuts of nice little bacteria that start creating that toxin, we then cannot get it out, right? So once that toxin's there, it's present in that ingredient. Unlike with the other pathogens that we can eventually cook out, if we get Bacillus cereus nice and happy so that it makes that toxin's just going to be there. So we want to make sure when we're looking at our hazard analysis that we actually have all of the relevant risks covered in that analysis, that they are actually present and that we are actually assessing them. Next slide, please. The next component of hazard analysis is ensuring that our hazards are evaluated in the absence of control. And this is an issue that we see across the board with a lot of facilities that we go in and do assessments with. So they have this beautiful hazard analysis and they've assessed all of these risks, and they have done it in the presence of controls that exist in their system. And this is actually backwards to how it's supposed to be done. So when we walk through how we frequently see these in assessments, we see our flour identified there as our potential ingredient, and we have all these biological hazards. We have the Salmonella, E. coli, Listeria, Bacillus cereus. Do these need to be addressed? Yes. But then what typically tends to happen is that we end up jumping to that, what measures can be applied to prevent, eliminate, or reduce that hazard to an acceptable level. And we use this column here saying we have all these lovely controls in place to actually assess the risk of the ingredient. And this is a little bit backwards. So when we're doing our hazard analysis, we want to walk through this from this is our ingredient, this is our risk, this is the severity to the risk, and this is how we're controlling it. So with something like flour, there is a risk. We know that because of the way that flour, wheat grows, that flour is processed, that there is going to be a likelihood of Salmonella, E. coli, Listeria, Bacillus cereus being there. Why do we know this? Because the FDA has told us so. They have said, these are the risks that you need to consider when you're developing your food safety plan. They're going to be a fairly high risk that's going to be there. That's why they've asked us to call it out. And then we're going to continue working through this assessment to say, we know we need to control this. How are we going to control it? And so when we're looking at our hazards, we really want to ensure that we're assessing them in the absence of control, and that those measures that we're putting in place within our process are helping to control that hazard to an acceptable level. Next slide, please. Okay, so the next one we're going to talk about with ingredient hazard analysis is grouping of similar ingredients within our hazard analysis. And so this is completely okay. You can absolutely group ingredients that have similar hazards, but they have to have similar hazards. And so if we're looking at the ingredients that we've selected for this cake example today, for the purposes of my hazard analysis, I am going to group my baking soda, my flour, and my cinnamon. Why? Because they're all ambient dry ingredients. They all have fairly low water activities. They have long shelf lives. We're going to group these based on that classification. They all seem fairly similar to me. But when we actually get into the nitty-gritty of what the hazards are for these, we're going to see that these are actually quite different items. So if you can go to the next slide, please. When we look at our ingredient hazard analysis for these items, we see here again with our flour that we have a number of biological potential hazards listed. With our cinnamon, we equally have potential biological risks, but we see that there are a couple of different items there. We have a C. perfringens risk under our cinnamon that we don't have under our flour, and we have a Listeria monocytogenes risk that we don't have with our cinnamon. And then when we get down to our baking soda, we actually have no biological risks, right? Same with our chemical hazards here. So we have potential chemical hazards called out for our flour. Maybe we have a potential pesticide risk. We know that flour has wheat in it. Wheat is a primary allergen that needs to be given consideration to under our food safety plan. When we look at our cinnamon, we have potential risk for heavy metals. We have potential unapproved color or additive risk. And we also have that economically motivated adulteration risk. So as per the FDA, when we're giving consideration to our chemical hazards, we also need to be including things like economically motivated adulteration and radiological risks. The FDA does want to see that given consideration to as a chemical hazard. Again, with our baking soda, in this example, we don't have any risks that need to be considered. So by grouping these ingredients in our hazard analysis, we're either over controlling something like baking soda that doesn't have any potential risks, or we may not be applying the correct control methods to our ingredients of our flour and cinnamon because they may have been identified as not having the full suite of risks because they actually have different hazards, right? So we want to make sure that when we are grouping our ingredients, that they all have similar hazards, even though with this example, flour, cinnamon, baking soda all have very similar, ingredient characteristics. But from a hazard analysis perspective, they need to be identified and controlled separately because they do have different risks that they pose to our product. Next slide, please. Okay, and we're going to move on to now what I've called these RTE ingredients. So in my cake example here, we have this nice slab cake that we manufacture, we make on site. But in addition to having our individual slab cakes that we're selling, we're also selling these prepackaged product where we make our slab cake, and to that we add, let's say, an icing and a walnut package. That way the consumer can take it home, they can make a nice iced cake with some nuts on it. Those icing and those walnuts are not something that we are manufacturing on our site. We are buying them from somebody else. They've already manufactured it, they've pre-purchased it. All we're doing is adding it to the kit. That being said, within our hazard analysis, we still need to give these consideration, and they still need to be considered as they would any other ingredient in our hazard analysis. So even though we are not manufacturing them, we are just bringing them in and adding them to our product, they are still an ingredient and they are still going to be sold under whatever our product is, right? So we still want to make sure that we understand the risks and that those risks and hazards have been controlled. So are these, if you have ingredients within your facility that are these RTE ingredients, have you given consideration to them? Are they in your hazard analysis? Have they been assessed in the absence of controls? So again, with something like our walnut here, we need to ensure that in our hazard analysis, we are showing that they have a potential salmonella risk. There is a potential mycotoxin risk. And again, maybe there's that allergen risk because maybe they're manufactured in a facility that manufactures a number of different types of nuts. And while this is one type of tree nut, maybe they manufacture with a bunch of other different types of tree nuts that we need to understand whether there's a potential hazard there. What hazards may the supplier process have introduced? So when these products were manufactured, are there considerations that we need to give within that process that may be a risk to our ingredients that we are bringing in? And then have you fully controlled these risks? And so we're going to get into these control measures a little bit more further on in the presentation. But when we look at this, again, FDA, next slide please, is going to provide guidance around what risks need to be considered within our process. And so when we are doing our hazard analysis, we can go to these tables and say, okay, we're buying this packaged good. What do we need to give consideration to? Do we need to consider things like potential pathogen recontamination, potential for metal shavings, depending on the process that they're using? Is there a potential for allergen cross contact? And so again, with these ingredients, if they're being manufactured elsewhere, it is still, the onus is still on you as the manufacturer to outline these hazards in your hazard analysis, ensure that they have been adequately controlled so we don't pass that potential on to the consumer. Next slide, please. Okay, so the next area we're going to talk about is process flow and how some of the common issues we see with process flow. So the best way to control hazards within your process is to fully understand the process. And by fully understand, I mean understand what each and every part of that process looks like. So if we can go to the next slide, please. So some of the common errors we see are around missing and grouping steps. And so again, when we're missing or when we're grouping steps, we may not be able to fully control the hazard that goes along with those steps. So some questions we should be asking ourselves when we're taking a look at our process flow is things around how our ingredients are received and stored. It's very common to group these as one sort of category. We receive, we store, then we make, right? That being said, there are inherent differences in the hazards that need to be considered when we have a bulk receiving versus something that's received cold versus frozen versus ambient. And as these all have different potential risks, potential hazards that need to be considered, they need to be outlined separately, right? Because if we're receiving something bulk versus something that's in a 50-pound bag that we're putting on a shelf, they are received very differently, and that needs to be called out in your hazard analysis. How is packaging received? How are we bringing that into our facility? Are there any things that need to be considered there, especially things around allergen labeling? If we have allergens, are we reviewing our packaging? Is this called out as a potential hazard in our hazard analysis? Do we have this step on there? What unique or different steps do ingredients go through? So when we're walking through our process, we need to ensure that unique and different steps are all accounted for. Do we have transfer points between steps? Are they on our process flow? Where are those touch points between steps? So are we physically handling the product? Does that add a potential hazard that needs to be considered? Have we accounted for things like magnets, screens, sieves in the process? If we are using them, are they actually on our process flow? And then again, where are those labels being applied? So where are we putting a label on our product? That has an important part of allergen control. And then if we are mixing or grouping our steps, are there things within those steps that need to be considered separately? So again, in our bakery example here, maybe we have a mix of ingredients step, but really in reality, what we have is something like a weigh step included in there, a screen step, maybe we have a magnet, maybe we have a transfer step, and a storage step that's prior to baking that all needs to be considered here. So if we are looking at individual steps, are there components within that step that need to be called out because they may bring separate hazards to our process? And then are there waste streams or utility inputs? Are they all included on your process flow? So next slide, please. So here I've created us a nice simple little flow diagram for our Cakes R Us bakery. It's a fairly simple process. We receive ingredients, we store them, we mix them, we take those mixed ingredients and we bake them, we make them into a cake, we package, we freeze, we store, we send it out. Seems like a fairly simple process, right? But when you actually break that down, if you can just click now, it will show up. The process flow may actually look something more like this, where we have our receiving of our bulk ingredients, our storage of our bulk ingredients, again, our receiving and storage of our ambient ingredients, our individual steps. So where we may have once had just a mix step, maybe now we have a weigh step, a dry step, a transfer step, a screening of our ingredients. So really when you're walking through, ask yourself, is this something separate or different that is happening to my ingredient that needs to be considered? Because all of these steps may have unique hazards that are associated with them, and without calling out that step as a specific individual step, we may be missing something. So really go through and ask yourself, have I accounted for all of the potential, steps, transfer points that my product goes through? So next slide, please. So how do we go about ensuring that completeness? Walk the floor, follow that process. Make sure that you can account for all processes, transfers, touch points that your ingredients undergo before they become that final finished product. Why is this important? Because each step has potentially different hazards that may be important that need to be called out at that individual step. Each step has different control measures that maybe need to be implemented. So by not calling that out, maybe we haven't done a good enough job of controlling that potential risk. And so without including each step, we might miss an important hazard in our flow. Next slide, please. Now we're going to switch gears and look at the control measures that are implemented. So when we've identified all these really nice hazards. Now we need to control them. And so it's important that we make sure that we are adequately controlling them within our hazard analysis. Next slide, please. So when we are looking at the control measures implemented, we want to ask ourselves, do they adequately control the hazard that we've identified? How are we actually controlling that potential hazard? Are we using a prerequisite program to control it? And if we are, is it fully controlling the identified hazard? So if we have identified that we are using a preventive maintenance program to potentially control a foreign material risk, do we have the records to back that up? Can we show that we have done our maintenance at the prescribed times that is going to help to ensure that we control that risk? What proof do we have? How have we identified the fact that that program is actually controlling that risk? And then if we have things like our critical control points, are they fully controlling the hazards identified? So do they actually control all of the hazards that identified, or do we need potentially multiple steps to control all of the hazards that have been identified, needing that control? Next slide, please. So when we're looking at our control measures here, we're going to go back to our nice little flower example. And so here we're going to switch focus and look at the chemical hazards that are associated with that flower that we're bringing into our facility. So the FDA in the Appendix 1 has called out the fact that there may be the presence of mycotoxins as a risk, and there may be the presence of pesticides as a risk that need to be considered with flower. These are not something that within our process we're going to be able to take care of. These are something that are going to be, these are our hazards that are going to be controlled before that product actually gets to us. And so when we are looking at these control mechanisms, our supply chain is going to have the onus of implementing this control. That being said, we still have the responsibility to ensure that our supply chain has adequately implemented control measures. So if we are going to say in our hazard analysis that we have implemented a supply chain control, we need to have proof that that supplier has actually mitigated that risk, that they have controlled that hazard before it gets to us. So when we're going through these control measures, if we have said supply chain, we need to ask ourselves, what do we actually have from our supplier to show that hazard is fully controlled? Next slide, please. So what might this look like? What could we have from a supplier that would help to show that that hazard has been controlled? So we're really looking for something that shows that they have proof of control in their process. Maybe we've gone to our supplier and we've done a second-party audit. We've asked them to walk us through what their process looks like and to say, okay, this is what we are doing. These are the measures that we've implemented to control that risk. We have documentation that shows we went and did this. We have all of the supporting information that shows, yes, we believe that this hazard has been adequately controlled by our supplier. So that's an example of a verification activity that we could be using to show that our supplier has indeed had that proof of control in the process. Maybe we're getting certificates of analysis for all of our ingredients that are coming in that have that risk. That's great. We want to have that certificate of analysis. We want to have that proof, but we want to ensure that on that certificate of analysis, every aspect or every hazard that they have said that they are controlling is actually mentioned. So if we have identified the fact that we have a listeria risk, a salmonella risk, an E. coli risk, and we're buying a ready-to-eat product that our supplier is responsible for removing all of those risks, we want a COA that shows we have no E. coli, we have no salmonella, we have no listeria. Same for those mycotoxins or those pesticides or any of those potential, heavy metal risks that might exist. If they are the ones that are responsible for getting that control, we have to have that proof. So if we are using a COA, make sure that that COA actually shows results for that hazard. And then we want to make sure that we're really testing that system. So can we go back to our program and show that, yes, this hazard has been controlled? Do we have that guarantee from our suppliers? What documentation exists that actually states our mycotoxin risk was controlled, our pesticide risk was controlled? If we don't have that, then we cannot conclusively show that our supplier has controlled that risk. And so GFSI is a great tool. It's great for part of our supplier approval program, but a GFSI certificate is not enough to show that a supplier has actually controlled a hazard that we may have identified within our process. So what we are specifically looking for is something related to that ingredient. So if we're bringing in an ingredient that needs to have that supplier control, we need assurance from the supplier that they are actually mitigating that hazard around that ingredient. GFSI is going to look at the entire process. It may look at the risks or the hazards that they've identified and how they're controlling it, but we need something that goes down to that ingredient level. Next slide, please. Okay, switching gears a little bit here and looking at our critical control points. So again, with our flour example, we have identified the fact that we have some pathogen risk. We have Salmonella, E. coli, Listeria, and Bacillus cereus. These have been identified as risks related to our raw ingredient, and then we're going to control them within our process. A fairly typical way to control things like Salmonella, E. coli, and Listeria is through cooking. We run it through a cooking step, we reduce the risk of it being there, we kill those potential bacteria, our product is fine afterwards, right? So we have our cook step, but really our cook step is only geared towards those vegetative, non-spore formers, non-toxin producing pathogens, which really begs the question, what are we going to do with our Bacillus cereus? And so again, in our bakery example here, we have a hydrated batter. And the second we hydrate that batter and we give it the potential conditions that it needs to grow and to potentially produce that toxin, we need to ensure that we have a control in place. If we're making that batter and we're storing it for any period of time during our process, or we're not cleaning our storage vessels between batches, do we have the potential to have that growth within our product? And if we do, then we need to understand things like how long can we actually store it? What time and temperature is acceptable to reduce the potential formation of toxins? Because once we have those toxins formed, we cannot cook them out. They will just be in our product. So when we're looking at something like flour, we want to ensure that if we are implementing critical control points in our process to help mitigate that hazard and reduce that risk, that we are actually accounting for all of the potential pathogens that are present. Next slide, please. Now we're going to look a little bit at the cooling step that's been implemented with our cakes. So we're cooking it, we're bringing it out of the oven, and we're cooling that product so that we can package it because we don't want to package it hot. But during this step in my process that we've created here for our bakery, we do have the potential risk of environmental pathogens. So at this point in our process, we may have Salmonella in our environment, Listeria in our environment that could potentially contaminate our nicely cooked product, right? And so here we've implemented that sanitation control. We are going to sanitize and make sure that at this step, everything is clean, that we don't have these potential organisms in our environment to recontaminate our food. This is a fantastic control measure. We're going to implement our sanitation program. We're going to do some environmental monitoring of that area to ensure that our exposed, fully cooked product is not at risk from these potential hazards. That being said, if we are going to implement that program and we are going to verify it with monitoring, we need to ensure that we actually have the resources to do so properly. So if we are going to use this as a control, it's probably not enough to say we're swabbing once a month, we're swabbing, once a quarter. We need to really be looking at the frequency with which we're swabbing and making sure that we can control that risk. And then we want to ensure that we have the resources to be able to provide that control measure. So can we adequately swab to show that we have control at this step? Next slide, please. All right, so in summary, our hazard analysis is a robust tool to help identify and minimize food safety hazards, but we do see some common errors with these that we have discussed here. So really, it's really important to go back and evaluate your ingredient hazard analysis and ensure that we're doing things like assessments in the absence of control, that we have fully covered the potential hazards that exist with our ingredients, and that if we are doing those groupings of ingredients, that we understand that they do have similar hazards. And with those RTE ingredients, new criteria for hazard analysis is to really evaluate what's happened in their process beforehand to ensure that we can say that that hazard has been fully covered. It's fairly common to see some process flow issues. So when you're going back and reevaluating your process, ensure that we have all of those touch points covered within our process flow. And then what are we truly doing to control those hazards? Do we fully understand, and what proof do we have that those control mechanisms have adequately been implemented? Next slide, please. So I'm going to leave you with this question today. How well do you truly know your hazard analysis?
Kate, thank you so much. So first things first, this is all about how well do you know your current HACCP plan and all of the processes and controls within that plan. And obviously, with supply chain issues that have been currently happening, with other, scrambling to find new suppliers and things like that, you've got to make sure that that plan is up to date. Kate, you brought a lot of attention to the supplier side. But before we go down there, I really do want to bring us up to the theme of those process flows. When it comes down to those specific steps, what, in your opinion, based on all the conversations you've had with food manufacturers, what are the most commonly overlooked steps in their hazard analysis plans?
I think a lot of times people have screens and magnets in place that they don't call out in their process, which they absolutely should because they're there for a reason, right? They're just included because they're, part of our storage tank, or they go through them as part of a transfer step from our storage tank to our processing, whatever that looks like. And you go through and you're like, that's there for a reason. That's there because it's helping to mitigate a potential foreign material risk, or because it's helping to reduce, whatever's going on, and call it out, take credit for it. You're doing it. And it is actually helping to mitigate a hazard that you've identified potentially, right? I agree with the comment there too. Outsourced processes. Do your products go out somewhere? Do they come back in? Does that need to be considered? Have you actually got all of your utility input? So are you using air in your process? Are you using, water that's an input into your process? Make sure those are accounted for on there. They need to be considered.
Right. If you're going through your HACCP plans and you're discovering, geez, we don't actually have all of our steps, what is the best way? I know we have a lot of folks in, say, quality, food safety. What is the best way for them to drive awareness to going through this plan and getting it updated and getting the proper approvals for that?
That's a great question. I mean, I tend to be of the belief that more information is your friend, because
Yes.
it helps you to better ensure that you are making safe product. And so, if you are missing, you do have gaps in there, go back to what the regulation requires, go back to what, the requirements are through HACCP, and say, hey, what, we're missing some of these, and these are fairly key components that need to be considered to make our food safety plan effective, to ensure that we are doing the best job that we can to control these hazards. And I'm not sure that anybody's ever going to, say, oh my goodness, look at that. We're not going to support you to do that. And if they do, I would be asking questions as to why they're not supporting that. So, I mean, certainly if you can build a case to say, hey, what, we need to give consideration to this, I can't imagine that anybody's going to say, sorry, you don't have our support here.
Yeah, I think more or less it's probably around awareness of the situation. So is it good enough, or should it be really good? We don't want to skirt through this. That's dangerous. And that goes back to your comment earlier about, GFSI recognized certifications. It's not just because you have it or your supplier has it doesn't necessarily mean what you're providing in your food is absolutely incredibly safe. You have to have other controls in place. Which brings me to the next question around proof, showing proof. You did bring up a couple of examples of that, but overall, there's a ton of documentation around making sure that you're covering all your bases and showing proof of that. Can you provide any guidance to how you can manage all of that information, the proof points, the control documentation, everything that you have? What is I guess, a standardized practice that you might maybe not give us here on this presentation, but are there resources that can help folks kind of get things more consolidated and in a more organized way?
That is a great question. And really, I suspect at the end of the day, it depends on the size of your company and the resources that you have available. I think a lot more, with digital records, it's a lot easier to have all of this documentation in one spot. It's easier to manage because you can keep all of the COAs in one spot and easily find them. And I think certainly the shift towards digital records is helping to enhance and make it a lot easier for companies to control this, as the amount of paper that you have to store and keep and go through has been minimized because of these. But I don't know that I have a good answer to that, because it really depends on how your company is set up.
Right.
The size of your company too. I mean, how many people do you have to manage this? That needs to be something that you give consideration to. Is there one person? Is there 10 people overseeing this? But I do certainly think the shift to digital and the platforms that exist to fully manage documentation has been a big help to the industry in ensuring that they have everything they need for that proof aspect.
Right. Going back to that proof. So, for example, we were talking about suppliers. So if a supplier claims control of a hazard, but you don't have the direct verification of that, how do you actually put that into your documentation? If, let's say, the auditor, an auditor is coming, and you don't have necessarily all of the proof or verification from that supplier, how should you prepare?
I would be reaching out to the supplier to ask for it. If they have controlled that risk, or that hazard, they should have something that says that they have controlled that, right? Or you should be, doing that due diligence before you're actually using the ingredients from that supplier. So whether it's going there and auditing them annually to say, hey, you know what, you're still doing exactly what you say you do. We believe that this is controlling that potential hazard.
Right.
So the onus is as much on you as it is on them to ensure that that risk has been controlled.
Okay. And that's really the big challenge I think a lot of folks are seeing now is
Yeah,
getting the right information in a timely manner that you can actually provide proof that what they say is true. And we're not picking on suppliers, but it seems to be very challenging, and not everybody has the resources, like you were just saying, to provide all of that information in a timely way. So,
correct.
yep. This comment just came in. We tend to see many forgetting the rework pathways and the possible need for controls during rework.
Mhm.
Yeah. Yep.
Absolutely.
Yep.
If you are doing any sort of rework, whether it's repackaging, whether it's opening, whether it's reformulation, make sure it's on there.
Now here's an interesting one. You were talking about grouping ingredients for hazard analysis. Where do you draw the line between similar enough and too different? So I know you showed a couple of examples of that, but yeah, where's that line?
So I actually think the FDA has done a great job in their guidance documents of helping you with that. So if you go to Appendix 1 and
Uh-huh.
you're looking up your ingredients or whatever you're bringing into your facility, and they are in that same sort of grouping category, consider them to have similar risks, right? So
Mhm.
you can go and say, okay, my nut example there, if you go there, it's walnuts, cashews, pecans, like all of those nuts will be listed there. Do they need to be considered individually? Nope, they're going to have similar their hazards. But if I'm looking at something, like a fully heat treated nut later on, then maybe that's something that needs to have different consideration. So certainly use the information in Appendix 1 as your friend and say, okay, you know what? They've done a pretty good job of grouping the things that they believe have similar risks. And so if they're grouped, absolutely leave them that way. If they're not, then take a look at the hazards and say, okay, are we going to have similar hazards here? And do the control measures implemented? Are they similar? And if they are, then maybe you can group them. And if they're not, then give some consideration to how we assess them moving forward in our hazard analysis.
Yep, that makes sense. All right. I think we'll wrap it up here for now. As always, we would like to leave you guys with a lot of resources from the Acheson Group and SafetyChain, which, again, we've been partners for, geez, I can't even say, about 11, 12 years now, and built a library of excellent resources for everybody to tap into. This is not just for hazard analysis. This is food safety overall. So best practices, tips, tricks, tools, you name it, we've got it. So please do check out those resources at the achesongroup.com or safetychain.com. And Kate, we appreciate you again for coming back and sharing a little bit more about what to look for when you're dusting off that old hazard analysis that you might have inherited.
Thank you so much again for having me.
Okay, well, everybody have a wonderful weekend ahead, and we look forward to seeing you all again on FSMA Friday. Take care.